Hello, Gary Parker here. Hope you're doing okay in this new society of isolation. Just wanted to talk to you a little bit about what statistics is so you know what you're getting yourself into. Maybe. There we go. So there's a couple of different parts of statistics. There's descriptive statistics and inferential statistics. So descriptive statistics is where we have some data and we want to describe it to somebody. So for example, a simple one here is I was keeping track of, what do I usually do in a day? And I spend time making and eating food, and I spend time working and playing around with stuff, in the yard with my cat, riding my bike. Although I guess the bike riding counts as exercise, and so does sometimes playing with my cat. Anyway, chores. So I can make a pie chart to display that table of data. There's all different kinds of charts that we make. So here's one when I pay my water bill each month. The city sends me, hey, this is how much water we measured that you used in the last several months. So bar charts are popular. Pictographs are used a lot. So here's a silly one with the number of cats me and some of my friends have. Dot plots are kind of popular. Here, the number of times each day I asked my daughter to clean her room in the past month. So you can see the distribution of 3 times in the last month were days I didn't ask her. And then some days I asked her 1 time, and a whole bunch of days I asked her twice to clean her room. Every once in a while, like once last month, I had to ask her more than 7 times to clean her room. As your parents, you understand that problem. A line graph is usually used for data over time. And so different years, percent of women with college degrees in the labor force versus men. And we can see that women are about to surpass men this year, which is kind of cool. Many other kinds of charts to analyze data. For example, a site we'll use later called StatKey. And let's take a look at what's a good data set here? I had one in mind earlier. Exercise students. So here they have a dot plot. A bunch of students were surveyed and they were asked how many hours they exercise each week. So we have one student that says he exercised or she exercised 40 hours in a week. A whole bunch said 10 hours in a week. And each dot is a different student. That can be displayed in different ways, like a histogram. So this is a bunch of students, 60 students, exercise 0 to 5 hours. And then over here, we've got 106 students who exercised 5 to 10 hours. And each column has a different grouping. And so when I point to a column on the right here, it tells me about that column. So for example, this middle one, 86 students exercised from 12 to 16 hours. Histogram is a way to summarize a big set of numbers to people. And this summary table is more meaningful than just a big list of numbers. Right? Big lists of numbers aren't all that meaningful to humans, especially if the list is really big. Okay? And that's not a huge list, but it's big enough that I can't wrap my mind around looking at the table. Let's see, there were how many numbers in there? 361 numbers. So descriptive statistics is about taking some data and then describing it in a way somebody can understand. I collected from a hospital in Pennsylvania a birth weight of newborns. And so I can calculate these summary statistics about those birth weights. I can make charts to help other people understand the birth weight. Why are there some babies that are relatively light compared to the others? Why are there not many that are relatively heavy compared to the others? So all kinds of things descriptive statistics can help us with. Then we jump into inferential statistics, and that's making predictions. So there's a lot going on with COVID-19, and how long does it take for someone when they're exposed to end up with symptoms showing that they have the disease? That's an incubation period. And I found a link to a study that claimed the median incubation period is about 5 days. And so I was curious about that study. And so they had, let's see, that's not the details. Here we go. Details of the study, 181 confirmed cases, and they were trying to identify the day of exposure of the patient, and then around when they first started experiencing symptoms. And they give a whole lot of details about how the study was run, how they made their calculations, and we'll learn a little about this right here so that by the end of the quarter we'll be able to read this report and understand more than half of it about how they came to the conclusion that the median incubation time for COVID-19 is about 5.1 days. So we're going to work on doing that. And again, in order to understand the predictions that we make based on numbers, we have to understand how we go about describing big sets of numbers. And that is statistics. It's pretty important stuff in our world today. And my hope is by the end of this quarter, after all our struggles together, you will have a good grasp about how these numbers that are thrown around in the media came about. So I'm looking forward to working with you this quarter. Again, my name is Gary Parker, and we will have some fun with statistics. Thanks. Bye-bye.